Hello, ladies and gentlemen. It's Mrs. Notzel. Welcome to our last week of e-learning. I cannot believe that we are finally at our last week, and I cannot believe that we've had the last 8 weeks doing e-learning. We miss all of you so much, and we would much rather be in the classroom with you, teaching you and working with you than at home doing this via online and via Google Meets. So this last week, we're working on symmetry. So hopefully you guys have worked with some symmetry before, but we're going to work with some symmetry today. And then we're also going to do some interactive slides for Tuesday. So we hope that, the end of the math unit will be kind of a little bit more fun than what it normally would be. Okay, just like if we were in school. All right, so this week our lesson is on symmetry. So we've learned about shapes and lines, and now we're going to learn about a special line that has a particular purpose called a line of symmetry. So it says each of the figures below has a dashed line drawn across it. Imagine folding each shape along the dotted line. If the two parts would fit exactly on top of each other when the shape is folded, draw a star on that shape. Okay, so if we folded this over this, would it match up completely? Is this a mirror image of this? And the answer is yes. So sorry, it's kind of a funny star. Then we have this isosceles triangle. If we draw this line right down here, and if we were to fold it over on that line, okay, so let's see, I have an isosceles triangle right here. And if I folded it over on my line of symmetry, does it match up? And the answer is yes, it matches up. So we're going to draw a star on this one as well. Okay, now we have a rectangle. And we have a diagonal line of symmetry. So if I try to fold it on that diagonal line of symmetry, my sides are not going to match up. They're not going to match up when they have a diagonal line. So I'm not going to draw a line there. And I forgot to show you the square. Here's my square. And if I fold it over, it matches. Okay, now I have my circle. My circle, if I fold my circle on that line of symmetry, am I going to get, is it going to match up? And the answer is yes. So I would draw a star on this shape too. And then I have a right triangle. So remember, a right triangle has a 90-degree angle right here. So if I were to fold it on that line, I can see that they do not match up. So I would not draw a star on that shape either. Okay, now we're going to go on down to here. It says trace the square, which you guys will be filling in the answers on this, so you'll want to listen to me in the background and fill it in as I'm filling it in. So I traced the square and I included the dashed line. It says cut out the square and fold it on the dashed line. Do the two parts fit exactly on top of each other? And the answer is yes. So I already have the text box here for you. I'm just going to erase those and I'm going to write yes. Okay, then it says, now trace and cut out the rectangle. Make sure you include the dashed line. When you fold on the dashed line, do the two parts fit exactly on top of each other? Why or why not? And the answer is no. So we're going to put no right here. And the reason why is because on a rectangle, we have opposite sides are the same. But so if we folded it this way along the opposite sides, or if we folded it down the middle, then they would match up. But the diagonal lines don't match because it's the opposite sides that match. Okay, Like in a square, you can fold it this way, you can fold it long ways, you can fold it diagonally, and it's all going to match up. Okay, so no, because on a rectangle, only the opposite sides match up, not when a diagonal line is drawn. Okay? Says which other shapes are divided into two parts that fit exactly on top of each other? Well, that's easy. We already went through these shapes. And so we've talked about the square and we talked about the rectangle not fitting. But the two other ones that have stars on them are the isosceles triangle and the circle. Okay? So those are the two other shapes besides, oops, I think I spelled this wrong. Besides the square that we already talked about. Oops, I'm sorry, I went too far. All right, which other shapes are divided into two parts that do not fit exactly on top of each other? Okay, which other shapes? So it's the rectangle and the right triangle. So I would put rectangle and right triangle. And I have to get specific in my description of the triangles because there's two separate triangles. No, letter E says, describe what parts that fit exactly on top of each other look like and what parts that don't fit look like. Okay, so, oops. Sorry, I wanted to move that up a little bit. So describe what parts that fit exactly on top of each other look like. So when they fit on top of each other, they look like a mirror image, right? They fit on top of each other. There's no overlapping. So when the parts fit exactly, they are a mirror image. There is no overlapping. Like on the rectangle, when you fold it, there's overlapping and it doesn't match. Okay? The parts that don't fit overlap each other and don't match up perfectly. Okay? So that kind of explains the lines of symmetry. So basically, when you are looking to draw a line of symmetry, when you're looking at a shape and it's asking you to draw a line of symmetry, what you're wanting to look at and what you're wanting to do is you're wanting to make sure that that shape can, you can either look at it and say, oh, is that a mirror image on the other side? Or if I folded this shape, would it fit exactly on top of each other? Okay, so that's what you want to focus on. All right, in the problem on the previous page, you tested folding each figure along a line to see if the two parts fit exactly on top of each other. When you can fold a shape on a line and the parts line up with each other, the line is called a line of symmetry. Lines of symmetry were shown on the square, the isosceles triangle, and the circle. Shapes can have more than one line of symmetry. All of the lines of symmetry for a square are shown on the square. So it can go horizontal, it can go vertical, and it can go in diagonal across the two different sides. So there are 4 points of symmetry that pass through the center of a square. This scalene triangle has no lines of symmetry, because if you try drawing any lines in the triangle so the parts fit exactly on top of each other, you'll see that you can't. There's no place, you can't draw on any of the sides or edges. You can't draw it from any of the points and get it to fit exactly on top of each other. To the right are 2 different quadrilaterals. The rectangle has 2 lines of symmetry because you can go horizontal and vertical, And when you do that, the shapes will match up. But the other quadrilateral has no lines of symmetry because of this odd shape out here. If you were to draw a line here and fold it, it would not match up exactly. So now it says, describe a shape in your classroom that has at least one line of symmetry. So if we were in the classroom, I would probably say the TV, okay? The TV is shaped like a rectangle, so it would have at least one line of symmetry. And you can also see a TV at your house, so you would know that it has a line of symmetry, okay? You don't have to put the TV on your example. You can put something else, all right? All right, and then you have one more thing to do. Along with filling this out with me and going along with me, you have one more slide, and it says, which shape has 4 lines of symmetry? An isosceles triangle, a rhombus, a square, or a rectangle. Now, if you want to use a tool to circle, you can do that, or you can just highlight what your answer would be. And then for number 2, it says, each shape below has side lengths labeled in units. Determine the number of lines of symmetry for each shape. Draw each shape in the correct box. Some boxes may have more than one shape. So this rectangle right here, I want you to click on it, and then you can actually drag and drop it. So a rectangle has how many lines of symmetry? If you think it's 0, then you put it here. If you think it's 1, you move it and put it here. If you think it's 2, you move and put it here. So wherever you think it goes, you move and put it there. And so if you click on each one of the shapes, you will find that you can drag and drop it. Okay. And there might be more than one shape in a column, and there might be some columns that have no shapes. Okay. There's only 1, 2, 3, 4, 5 shapes. And yes, there's 1, 2, 3, 4, 5, 6 columns. So you know that you're already going to have a column that doesn't have a shape. Okay. You put each shape in one column, but like I said, some of them might be like, you might have 2 that have no lines of symmetry, or you might have 2 that have 1 line of symmetry. Okay. So you can have more than one answer in a column, and there can be some columns with none. Okay, ladies and gentlemen, I think you'll do a fantastic job. Hopefully you understand lines of symmetry. If you have any questions, please reach out to Mrs. Davis or myself. We are here to help in any way that we can. We miss you all so much, and we hope to see you soon.